My name is Yohan Hartanto, and I've been working at Uber for 8 years now. So more recently, I've moved to CI and DevX, and here are some of the experience that we built up over the years at Uber. I thought to share it with you to get some inspirations and for your own CI. Okay. So just a short agenda of what we're going to talk about, just general principle of what CI and a bit of an insight of how CI is being configured at Uber and all the different components, and some of the secret sauce inside our CI pipeline. Okay, what's CI and CD pipeline? So here's some definitions that I took from Martin Fowler's website. If you don't know Martin Fowler, he's very influential, and basically he talks about how continuous integrations is a practice of merging continuously the changes. But I think when he came up with this definition, it was like in the 2000s when CI was still early. I think these days everyone's follow this main branch development, and it's more than about merging a code. And so what's the difference between CI and CD? So if CI is about merging your code, CD is about the ability of deploying the latest in your main branch and whether it's ready or not for deployment. So what are the principles of, what is the goal? Why do we need CI or CD pipeline? The first one is quality assurance. Obviously, we want to detect any issue as early as possible. So this is not just an issue with the main branch, ability to compile, but also production issue. Like, does the code that you check in cause a bug in production? The ability to detect as early as possible is very important. And the other thing is consistent flow. I think without a CI/CD pipeline, you would have to write one book, a bunch of steps, and engineers will have to follow. This is what you got to do before you commit. This is what you got to do after you commit. And I think the last one that's really important to emphasize is CI and CD is a developer productivity tools. Without a good CI/CD, the engineers will have to do a lot of manual work to improve, to make sure that their code is in a good state and to make sure that they follow the same process as everyone else. So with that said, when we talk about CI, here's the principles that we're trying to meet in Uber. One is the automation, like trying to automate all the steps as much as possible. Ideally, an engineer should only do one or two steps and that's it, and everything is done. And we'll share on some of the things that we do to make this happen. The second principle is fast, and fast can be interpreted in two different ways. One is fast in the literal sense, which is whatever I have to wait, like the blocking time or the waiting time of engineers as in the CI process should be as small as possible. But the other thing that you'll probably see a lot in my slides is about shifting left. It's about, well, how can we even warn before the failures, warn the engineers of the potential failures that could happen as early as possible, during the development and even before they submit their PR. And the last one is actionable. Like whenever we present the result, whenever we determine this is the outcome of a CI or build or based on a PR, it needs to be very clear to the engineers. What do they need to do now? And the last one, this is what one of the secret sauce is the more you can measure your CI, the better it is for your customers, and also it provides a feedback loop to your own team on identifying what you can improve. And as an engineer, if you work in a big company, it will also help you to get promoted because you can show this is what I did. Like this is the impact of the things that I just improved. And so there's a lot of benefit of focusing on measurability very early. Okay, so what does it look like at Uber? So we use a monorepo, and I guess right now you could almost say almost a monorepo because we have multiple monorepos. We have Android monorepo, we have Go monorepo. We are working very towards to a single monorepo, just like Google, for example, who have a single monorepo. And inside this monorepo, we built so many apps. I think the last count that I had was I think we built about 11 production apps, and each app has their own variants, and they all maintained within a single repo. And we have all these different brands management, but the most important one is obviously main, and we have release brands, candidate brands, and development brands, and so on. Okay, just to show the scale, the different components within this monorepo, we have a dual build system. We use Gradle and Bug, which is our legacy build system, and we are in the process of moving away to Gradle and Bazel. I think we are halfway there, if not 70% there. And on a platform, we use Build Guide. We spend a lot of time the last 2 years migrating from Jenkins to Build Guide, which is a more cloud-based CI platform. And we use static code analysis heavily. There are so many rules, there are so many blockers, and the whole idea is about standardizing the code so that everyone follows the same patterns. It's easier for people to translate the code from one module to another. IDE, we use IntelliJ, which is our legacy system. That's kind of paired with Bug, and during this adoption of Bazel, we've also moved back to Android Studio, which has made a lot of our engineers happier. For code review, we use Fabricator, which I believe came from Meta, and Arcanist, which is a accompanying tool. So think of this as GitHub equivalent. Okay, just to show you the scales, our monorepo CI, so that my team is responsible managing, we do about 1,200 daily builds. Internally, we call them diff. So if I mistakenly use the term diff, that's PR. And we, as part of these builds, we have submit queue, we have PR builds. So when you submit your diff, it goes to this PR and then goes to submit queue, and we have all various builds. And we have CD builds. Once the code is landed, we have all these processes to trigger what we call post-land processes. And part of it is we do nightly testing where we send it to our QA team, and then when they're ready, we cut a build every week. To support this daily CI builds and the developer experience, we have about 100 daily, hourly, and 2-hourly builds, things like caching, monitoring, and detecting any flaky tests, any feature flag that's stale, and so on. Sorry. Altogether, I think it's very hard to get an exact count, but we have about 12,000 modules inside a single monorepo, and we use 5 different languages: Java and Kotlin for the production apps, and Python, Bash, and Starlark for our build toolings and variables to support the production of the app. Okay, so this is kind of a very simplified view of the stages in CI in Uber. So we have pre-submit, so this is everything to get that diff ready or PR ready. And then this is a chance as part of the CI process to introduce any early signals. So things that could go wrong, like your static code analysis that's incorrect, any stale feature flags, anything like that. We try to put that in as many as we can so that engineers, when they package their PR, they're feeling more confident that it's going to be green or passing the builds. The next step is the review. So this is the equivalent of the PR review. And this is where most of the checks will run. So as soon as engineers submit their PR and diff, everything's automated and triggering all these different builds and automated tasks. And we have a single status, which green means it's ready to land, and we send it to submit queue. Submit queue is our system to avoid conflicts, because the idea is we have about 100 commits landing every day. Sometimes in the peak hours, we might have 20 commits trying to be landed at the same time. So we need a system to make sure that only one diff is landed at the same time, and that's what submit queue is for. I think my colleagues last year gave a talk about how submit queue works at Uber, if you're interested to know the details of that. So once a code is landed, so the next step, once it's landed or once it passes the submit queue states, it will be on the main branch, and then that's when we triggers the CD components. And some of the checks, we actually defer until at the CD state outside the CI, and most of the main reason for that is just to reduce latency. And to give you one example right now, we're actively working on it, but like to build a release build, it's much slower than to build a debug build. So we defer building the final release APK until we get to the deployment, just to make our CI latency faster. because the ProGuard or the obfuscation states we found very slow. And typically the ratio is about 10 to 1, so for every 10 PRs, or PR builds, not PR builds, we only have one landed build. So this would reduce the cost and reduce the latency for the engineers who are waiting for a signal. Okay, so back to that principle. Okay, what do we do inside Uber to make everything automated as much as possible? So first one, we talk about this. As soon as a CI as soon as a diff or PR is submitted, all the builds are automatically triggered. There's no need for engineers to do any manual tasks if they don't want to. We have a concept of blocking builds and non-blocking builds, and this is to allow experimental code to still be landed on main. But the idea is we don't guarantee this experimental code will always be green. So there are times that these changes break, and that's okay, and that's why they're called experimental. And the other thing that we do in the non-blocking builds is do shadowing. Let's say we are experimenting with new build system, you are experimenting with a new emulator or device farms. We use this concept of shadow builds to get a percentage of how many fails in the production versus the shadow and so on. So this has been very successful to avoid the main branch fail because we introduced changes to CI. One of the things that we invested quite heavily recently is on the concept of automated reviewers. So as the team grows, as the code base grows, it becomes really hard to understand who should be reviewing every module. As you know, we have like about 300 engineers committing code to the Android repo, and it becomes harder. So the ownership concept, being able to assign an owner to every module, and then they get ping every time there's a review that's relevant, has been very useful. The other one that we have is we introduced a concept of auto LAN. So the idea is, well, if the CI build is green and someone has reviewed it and all the requirements met, we don't require engineers to go and click merge or do anything else. Everything will be sent to the submit queue automatically, and then they will just get a SAC notification, your build is now landed, and your code is now landed. And one thing that we've been working on recently is also the idea of trying to push the build as far as we can, because we notice there are many changes such as like library bump, major refactoring. These kind of changes affect many modules, and with the traditional CI, which follow the fail fast principle, it becomes hard to find all the things that they need to fix or to address. So we introduce a concept of keep building on failure. So when you submit your PR, you can tag it with keep building on failure, and this will just keep trying to build and push as many changes and identify as many errors as opposed to fail fast for most of our PRs. So that's on the automated. Some of the work that we worked recently is code coverage, which we focus a lot on this, and we in our this is like a preview of how our PR or diff UI looks like, and as part of the review process, the reviewer can also see which code has been covered by tasks and which code hasn't been covered by tasks. And this is also a good reminder for the engineer who submit the PR that, oh, actually, I still have a lot of things that I haven't covered. So we also provide this kind of summary. And so it takes a lot of the guesswork out of the submitter and the reviewer. And I think if any of you work in the CI system or dealing with CI, flaky tests is very costly. So a lot of investment have been made recently in Uber to build a tracking of all these flaky tests. Internally, we call them Testopedia. So the idea is we have regular monitoring. You know, as I mentioned before, we have this hourly job that running every single test in the monorepo and then track the status, the failure, how long it takes, and then we build this historical data to analyze which test is flaky. And if something is flaky, we automatically disable it. We create the Jira tickets for the owners that, look, you know, you got to do something about it because the cost of flaky tests is very expensive. And as an engineer who owns the test, fix the or improve the stability of the test, the regular monitoring job will move them from flaky to stable, and they'll automatically be run again at the CI time. Okay, so we talk about automated and fast. Obviously, this is a very important aspect of it. No one wants to wait for hours to know whether they can land their code or not. And this goes back to that definition of what is fast. And one of the mantra within Uber is what we're trying to do now is about shifting left. So the idea is, yes, we can do it at Summit Queue, but what if we can do it even earlier? And the idea of the shift left is to help the engineers to prepare their PRs better. And by giving them more confidence that their PR will land cleanly. And some of the things that we do is we invest a lot in IDE plugins. We use the marketplace plugins. We build a lot of in-house plugins. I think my colleague is going to give a talk about how to build an IntelliJ plugin tomorrow. So you can, if you're interested to build your own plugin, please come to that. And there are also little things that we do that is kind of nice with these plugins. As engineers working on their code base, they can get warned, okay, we are about to upgrade this new library next week, so be ready. And this is allow engineers to be prepared. The other thing that we do is we lean in on Git hook pre-commit heavily. So similar to concept of CI, so it's like a lightweight CI. So some of the things that are fast to do, like K-clean, K-format, we run that as part of the pre-commit. So by the time the commit is created and is sent to for review, it's already following the standard coding format. Okay, so fast in the literal sense now. One way to make sure that your build is fast, because I think 50% of the CI time is building, compiling code. We use a build cast. So I think if you want to learn more, there's like a link about what compilation avoidance and incremental compilations. We use bug, but the concept is the same in Gradle and Bazel. So the idea is if a module or a class has been compiled, how do we avoid recompiling again? And having this shared remote cast will not only just improve your CI build time, but also just the engineer's machine time, local development time. And one further optimization that we do is if you have dedicated CI servers, I think a lot of people use GitHub Actions, which is kind of the opposite of that. But if you have dedicated CI servers in your company, you can also create a shared disk cache, and optimizing this allows your build to go even faster. And it complements really well with modularization. We'll talk about that shortly after this. Okay. Well, how do you make things fast? So one of the things that we do a lot is to break down the build or the check into multiple tasks and then try to parallelize them. So just to give you an example, if you have a module with an app and you can run Gradle W check and it would run every single task, but if you split them into different commands, you achieve the same thing. So you can run a single command of Gradle W check with connected Android test, and this would run your unit test, your UI test. But if you break them down into 3, you can run them in 3 different servers, and you can get the end-to-end time much faster. And you can use things like Gradle Task Tree plugin or the scan option, and this will give you a nice sequence diagram of how the different tasks are executed, and then you can decide, okay, maybe this is how you should break it down. And you can use it to identify what the bottlenecks and dedicate those tasks into a separate server. I think a lot of discussions and other talks outside my talk, obviously, talk about how you can modularize your code. And CI, in terms of latency, it works really well when you modularize your code. So rather than kind of similar to breaking down your one major task into multiple tasks, if you break down your code from one module into multiple modules, you can run, for example, the unit test of feature 1 in this diagram, or this very simplified example, and the unit test of feature 2 on a separate machine. So then you can get another reduction in your end-to-end CI time. So if you want to take it even further, so this is the concept of what we call sharding or bucketing. So the idea is you don't just run different tasks in different servers, but you also break it down by the different module, and you're trying to create these different buckets. Because at the end of the day, the perceived time by the engineer is just the slowest part of your build. So if you break it down into 5 different builds, as far as an engineer is concerned, they don't know this, right? They don't see the 5 buckets, they don't care. All they care about is what is the slowest, and because that's the one that's slowing them down. So that's what we call about the longest shard. And it's a very efficient way to fasten your build without touching the code base itself. But it does come at a cost. I think that's the sharding, like the more machines you have, the more shards you have, it's actually a very inefficient way of using your resource because there are inherently repeated or duplicated subtasks within this. So it's a trade-off between time and cost. Okay. So we talk about automated, fast, and then actionable. So as we talked about before, as an engineer, if I see an error, it has to be very clear on what do I need to do now. And the last thing, I think the most frustrating experience for an engineer is they have to go through all these different logs, especially if you start sharding, then you have 5 different builds, and then they have to go through every single log of these lags to find what happened to them. So internally, we built this CI classifier system, and the idea is at the end of every build or every step or every shard, we run these reject classifiers to identify a pattern, and then we group them. And this is very useful. Not only you can identify what is the biggest problem with our infra, but you can also identify what are the common user failures. Like if they often forgot to check detect, then you need to invest in standardizing your detect plugin. If they often forgot that this kind of pattern is kind of a failure in our lint, then how do we build a custom plugin to warn them ahead that, okay, you gotta avoid these patterns because we're gonna block them. So a lot of these non-obvious things, you can learn your user behavior, I guess. Now, unfortunately, Gradle doesn't have a good standardized exit codes, but Bug and Bazel do, so you can kind of get a signal quickly. Is the error, is the build or test error because of out of memory, or is it because the test itself failed? But you can still use reject base by analyzing your log to do this. And the other thing, the concept of this fail fast also kind of goes hand to hand with breaking down into different buckets, different shards. By having a different bucket, it makes it even clearer for the engineer who submitted the PR. Oh, okay, my unit test was actually good, but my UI test failing. So that's what I gotta focus on. And you get an extra benefit, like you can kind of customize your configuration and so on. But that's, that's more for the engineers who maintain the CI than the customers. Okay, so a lot of the work that we do is also on how do we make it easy for engineers to recover. So let's say they know they have a failure and it's related to detect, but if you can summarize, and we talked about before, breaking down the task and modularization, if you modularize it to the point that every failure is for a specific module, then they can just focus on that module. So like in this example, rather than they have to fix the entire app or run through the test for the entire app, they know it's specific to this module and they just gotta fix that. And there's small things that you can do to make things easier, like things like lint or detect. They always have these artifacts, and if you attach it to the PRs, it makes it very easy for the engineers to fix it rather than they have to rerun the same task. Okay. So the last one is measurable. So this is something that we've been pushing a lot to as a group, as a team, because we are responsible for maintaining CI. So we have 3 kind of key metrics, or I think the official term is service level indicator. And those are LAN availability, LAN latency, CI validation time. So this is what our team who owns CI, we review every month to see what's happening. Every time there's a regression, we look at our logs, we look at all the other metrics, we talk to some of our customers to understand how we can improve it. So the key metrics here is availability, just like how many times an error occurs. So you want to get as much as possible close to 100%, right? Ideally, every single build or every single PR is always passing. And that's not to say don't run tests, but go back to that shift left. If you identify certain things that keeps failing, well, how can we prepare engineers better for those? And then latency is the turnaround time from the time they submit the PR until the time is landed. How long does it take? And validation time is more specific about the build time and the test time itself. Okay, so these three metrics obviously is not enough. So to support that and to troubleshoot whenever there's an issue, these are some of the metrics that we focus heavily. Just the volume of demand. I think engineers tend to work in cyclical. Like if this week you see a high volume, then next week everyone's already run out of their code. They go back to planning and so on. So this affects availability too. So by monitoring the volume, you can be prepared. Okay, do we need more machines? Do we need more parallelization and so on? And the most important one, the next three is more internally for our team to understand how well we do, how well we optimize our build. And the first one is the total build time and the longest job and versus the longest shot. So if you go back to that concept of every build consists multiple jobs and every job consists multiple shots, we always want to know what is the end-to-end time of everything, which is what we also use as our service level indicator. But also, is it unit test that's causing the latency, or is it lint, or is it UI test? Or is it specific bucket within unit test? And we can identify, oh, maybe this module has grown so big, and then we can then talk to the owner of that code to break it down so that we can run in multiple buckets as opposed to just one bucket. And what's very important is also capturing the slow and fail log. So it goes back to that concept of CI classification system. By keeping track of what is slow, so let's say your SLI for latency is 30 minutes, then you want to capture everything that's above 20 minutes. And then you can go back and identify what is the difference between these builds versus the other builds. And quite often it's the same thing. Like, is it caching did not hit? Is it they're not modularized enough? Is it there are repeated failures? And because sharding is kind of like it does require some algorithm to build this good sharding, we also put in a lot of effort into measuring the effectiveness of the sharding. So the longest shard, let's say you have 20 unit tests, 20 modules that have unit tests, and you break them up into 3, then the longest one is what the customer experienced. This is, this is what they're waiting for. And we also measure the total shards. Like if you add them up of all these buckets, those are how much cost you pay. If you using AWS, whatever, that would be close to your total expense for that diff. And the other one that we measure is this shard gap, which is the gap between the longest shard and the slowest. And this is very important to measure how effective your sharding algorithm is. So just to give you an example, let's say this is a common build in our diff. This is an actual PR build that we do. So if we take that 12,000 module and we break it down into 12 shards like this, the longest one is 30 minutes. So this is affecting what the user is waiting. And the shortest one is 5 minutes. And the total time is 83 minutes. So this means Uber is spending whatever the cloud expense for this 83 minutes. And if you run it in a single shard, I bet it's a lot faster than 83 minutes. But it also means, let's say it finishes in 60 minutes. That's still a very bad user experience rather than 13 minutes. So measuring the shard gap, identify, okay, like in this example, if we can optimize the code better or the sharding logic better, then ideally that 13-minute shard maybe become like 8 minutes. And then some of the targets are spread around in other shards so that as a user, I don't have to wait for 30 minutes anymore, and I only have to wait for like 8 minutes. But yeah. So that's short statistic. And I guess at the end of the day, just like you build a product, we built user feedback. We built a product for users. So it's very important to get a direct feedback from your users who are the engineers to do it. And every 6 months, we send out this net promoter score to our engineers, how happy they are with not only the CI, obviously, how happy they are with the DevX, how happy they are with the IDE, how happy they are with other toolings that we provide. I think, for example, like a few years ago before we fully adopted Kotlin, people keep asking for that, and it will show up that, people are not happy because we still haven't supported Kotlin. And there's also direct feedback. We provide a support channel for engineers who get hit by build problems that they don't know how to resolve, or they can submit a Jira. Okay, so it's not all great. There's just like building an app and a product. There's so many things in this kind of like our backlog of things that we still want to improve. So the concept is we have a CI of CI. How do we continuously improve our CI, both using metrics and user feedback? So identify these people who have really slow builds and understand, maybe you can partner with them. Can we refactor their modules to be more parallelizable? Or maybe they just have bad tests, like maybe they have a thread.slip in their test, and that's causing their test to be very slow. And a lot of the feedback that we get recently is about reproduction of issues. So this goes back to that actionability principle. If I get a failure and it's a UI test, and I can't reproduce it on my device, that's very frustrating, because now I can't land my API. So one of the things that we've been investing in is trying to build this emulator as a service. So the idea is we want the engineers to use the exact same device or emulator configuration that we use in CI2. And this would reduce that friction of I can't reproduce it on my machine. Right? And the other one is also flaky tests, because a lot of times engineers, when they run the test, they run tests specific for the code base. But in CI, we run 12,000 tests at the same time. We run all this multi-worker. So tests can be more flaky in CI because of that, because of these shared resources. And how do we reproduce the same environment and configuration? That's very important for us. And I think this is probably more a problem of a monorepo. As diff landed on top of each other, a lot of the failures is actually because they just need to rebase again to pull in the latest. And shifting left, this is what we're trying to do actively. We look at all these failures and how can we, for example, we talked about earlier about ProGuard, how can we build not only in CD but also in CI, so that if there's any failure, they know immediately. And equally, things that often fail in CI, how do we move it to pre-CI? Like, can we build like a intelligent plugin to detect this problem? And just as you see in the diagram before, we still have a lot of work that we can do in our sharding. How do we make it so that every shard is balanced so that users don't wait too long? And just in general, it goes back to that therefore productivity concept. We want more automated tests. We want to be able to detect leak canary, like there was a talk today about leak canary in tests, the version 3. So how do we incorporate that in our CI? How do we detect any app launch regression, any app size increasing, and everything? Yeah. So I speak really fast. So if there's any questions, happy to take a few minutes of questions before we wrap up. Yes. That's a very good question. So the question is, how do you balance between expense of the CI cost and the number of engineers you have? And I think there's no hard rule, but it goes back to the SLO, like what is the objective, what is the user expectations? What's more important is to understand, is 30 minutes a fast enough turnaround time for our engineers? And every organization, every company have different threshold. The bigger code base, obviously, the bigger the expectation that, okay, it's not going to be 5 minutes because we have 12,000 modules. So you work backward from there. And I think the way we've always done in the past at Uber is we start with that. And we put in, okay, well, if 30 minutes is what's everyone, I wouldn't say happy, but the content, right? Because 1 second would be the best, but, and then whatever the cost to get there. And then this is why all the metrics become important. Then we can say, okay, well, right now we only running 5 shards and all this. We can tune that. We can increase the bucketing, paying more costs, and that would bring down to 25 minutes. And then that's a discussion to have with leadership and, like, is this becoming too much now? And it's very easy to present your case to leadership that, okay, well, people say 40 minutes is not enough. So then we have 2 ways. We have to go back and refactor the code, modularize them more, so that we can parallelize it without paying server costs, or we just bite the bullet and we just pay more machines. Yeah, so I don't have a specific answer, but that's how we do it. Just all this data, and then you present it and you balance, you tune it up and down depending on what your company is happy with. Yeah.
So I'm going back to the slide where you mentioned 90% of Android code is mono-repo.
Yeah.
Could you expand on that? Like 90% of code for Android code for the entire company, including like all the brand keys, rider driver, design system, any other external libraries, they're all in one repo?
Yes, that's correct.
Okay. Like, why did you decide to go that route, and how do you, I guess, mitigate some of the effects of having a code base that large, like compilation time and stuff like that?
Yes. So when I joined Uber, we didn't have monorepo. So we have, I don't know, 100 repo. And what we found, it's very hard to standardize the library version, right? And then it makes it sharing code very hard. If I'm building a feature for Uber Eats, I integrate it to Uber Eats. Now I have to integrate the same module to the Rider app. And Rider app is using a different version of a library than Uber Eats. Now I have to go and update the Rider app first. And if I introduce a change, what I have to do is create an artifact in our local repository, the Maven, or I think a lot of people use Artifactory for that. And then you pull it down to the actual app repo and rebuild it. So there's a lot of cost associated in engineer's time. It goes back to the automated concept. Now, imagine I am the owner of this feature, then I have to create my own runbook, right? I will say, whenever you update this repo, you gotta then upload it, you gotta push it and download it in these following apps. And so that cost, it's gone if you have a monorepo, because you update something, every app gets it. Now, what is obviously it doesn't just go away, we pay it differently. Like you point out one thing, which is compilation time. And that's kind of the reason why we spend so much time on this, because build time was the biggest problem. If I'm an engineer and I'm making changes, I want my local build time to be really fast, right? And if you introduce this build cache, not only you get the things that you built in your Mac, but you get the things that other people already built. So that if you have 12,000 modules, you're only making changes to 10, and you pull in from main, the rest is already built. The rest is already built by someone else. So there's compilation time, and that's why we're investing in a lot of this on making it feels more or less still as fast, even though they now have to deal with 12,000 modules. The other cost is also whenever there's a library update. Now, the person who has to update the library has to make sure every single app is updated at the same time in a single PR. So that means they have to do more testing, more communications, like I'm running this code, make sure that you test it. I already did some high-level tests, looks okay, but you own this feature, you need to test it too. So there's a lot of this. But as far as developer experience concerned, it's much smooth. It's smoother. Everyone just doing the same thing. It goes to that like automated and actionable concept. You just do one thing, which is you make changes, you land it, and everyone's happy. Well, in the old world, there's so many ceremony to get your code actually roll out to production.
Yeah, that makes total sense. Just going Like, so when you push a PR for the rider app, for instance, are you running tests for like the design system, the internal libraries, since it's a single repo, or is it smart enough to only test the modules that are affected?
Yes, we actually only build the affected. So let's say, let's use this very trivial example. If we make changes to library 1, and library 1 is a dependency of feature 1 and feature 2, then we don't need to build feature 3. We don't need to run any tests of feature 3. But we would need to run tests that sits at the app level, and that's normally the UI tests. And you would run the feature 1, feature 2 unit tests. And the way we do this, we run dependency analysis using bug query, but you can do the same with Gradle dependency tasks, right? You can see, okay, well, what are the dependency of library 1? And then we only run tests of things that library 1 depend on. Yeah. Yes, and that's the idea of the concept of CD. By the time the code is landed, we create an APK of every single app. So it doesn't matter if library 1 doesn't change its, for example, only change rider app. We still build all of them anyway so that everyone can test and prove that there's no problem. And we have a QA that every night they do what we call core flow testing, and they take this app and test it. But there are additional tests that we do only for the weekly cut. So yes, we are ready, but we are more confident with our weekly cut because it has more checks. I think the principle is you cannot test everything in one place. So we have this concept of, well, some things will be tested using unit tests, some things will be tested in CI, some things will be tested in nightly, but as the effect of that test bigger, the more tests we do. Weekly obviously has the more tests because it runs everything plus this weekly manual test. No, the reason we don't do that is just so that people don't have to keep updating. I think in US, a lot of people have good internet, but because our customers spread all around the world, and there are some drivers in emerging markets, they actually would find a Wi-Fi first before they download the apps, and we don't want them to have the pain of updating the app every day. Sorry. So come meet me at the Uber booth if you still have more questions. Would love to share and exchange your CI stories. Thank you very much.